Hi. So today we're going to talk about, well, once again, algebraic expressions, but specifically combining like terms. So when we talk about like terms in algebraic expressions, we mean that can we add or subtract, and specifically add or subtract, numbers together, letters and variables, and things of that nature. So specifically, we can only add and subtract certain things together. Meaning, we can only add and subtract numbers together. We can add and subtract x's and x's, y's to y's, x squareds to x squareds, y squareds to y squareds. Okay, so it literally has to be apples to apples or oranges to oranges. Okay, so basically what I'm trying to say is that you can't take a number and add it to a variable. You can't take an x squared and add it to a y. You can't even take an x squared and add it to an x. They have to be the same, like the numbers, they both have to be numbers, or they both have to be the same letter with the same exponent. The exponents, we're going to talk about this a little bit later, is the number on top of the letters or the numbers. Okay, so when we get into orders of operations, we'll talk more about that in a little bit. So some examples that we have right here are, the first one that we have is 1x plus 1x. Well, they're both the same letters. Okay, so we can actually just add the coefficients. So 1 plus 1 would be 2, and then an x comes along for the ride. So 1x plus 1x gives us 2x's. Yeah. So here, for the next one, 3x squared plus 5x squared. Well, these are the same terms, the same variables with the same exponents. So we can just add the coefficients. So 3 plus 5 would be 8, and then bring an x squared along for the ride. Now this is where it's going to start getting a little trickier. Now we've got an expression with different terms in there. All right, so this is where we're going to have to be careful on how we group things. So I have 4x plus 7x squared plus 5x minus 3x squared. In this problem, I can only combine these x terms and these x squared terms. So I can only combine the reds to reds and the blues to blues. So 4x plus 5x, well, that gets us 9x. And then 7x squared minus 3x squared, well, that gets us a positive 4x squared. So it's basically combining the steps that we did in the previous two examples into one expression. So, and also too, it never hurts using colored pencils or different colored whatevers to denote your grouping. So that's what I did here, and in the next couple of problems, we're going to do the same thing. We're gonna group everything by colors. So for the next problem here, we have a negative 6x minus 2x squared minus 4 plus 3x squared. So you can hit pause real quick, see what you can do to work this out, and let's see what you get. Okay, so on this one, we don't have anything else that has an x with it. We don't have any other constants in here, but we do have multiple x squared terms. So these two guys are the only things I can combine together. Everything else just comes on down for the ride. So that negative 6x comes on down. A negative 2x squared plus 3x squared gets you a positive 1x squared. And then that minus 4 comes on down for the ride. Okay, so to clean this up, that would be negative 6x plus 1 times x squared is just x squared, so you can really just drop the 1, and then you have minus 4. And that would be your final answer. That would be your simplified algebraic expression. All right, let's take a look at a couple of more. Now, some of these examples do come from Newton. Some of them do come from some resources that I have. So you'll see a lot of these examples in Newton or something very familiar to it. So just keep that in mind. So for this one, we have 9 times x minus 3 plus 6 times negative 8x plus 3. So here we have to use the distribution property. So it does not hurt to draw arrows. So 9 is going to be multiplied by the x, and 9 is going to be multiplied by the negative 3. 6 is going to be multiplied by negative 8x. 6 is going to be multiplied by positive 3. So to write this out, okay, you don't have to do this next step if you don't want to. It would be 9 times x minus 9 times 3, and it's minus because of that minus sign inside the parentheses. And then 6 times negative 8x plus 6 times 3. Okay? So like I said, this step you don't have to do if you don't want to. You can just jump right to this one I'm just about to write. So this is the distribution. Okay, so this next step was actually what most people go with. So this would be 9x, or 9 times x, minus 27, minus 48x, because a positive 6 times a negative 8 would be negative 48, and then plus 18. So we multiply it. And then we have some terms we can combine. So I can combine the x's together, and I can combine the constants together. So a 9x minus 48, that would be a minus 39x, and then a minus 27 plus 18, that would be minus 9. And that would be your final answer. So here, combined like terms. Now, also too, the way I'm writing this work out, this is actually how it makes sense to me. Now, everyone has their way. It's okay. But I like to have my work on the left side, and then what I did on the right side. This is actually what's called the Cornell note-taking system. So if there's ever a reason why I do what I do, I'm always going to give that to you. I'm always going to tell you why I do it. So, but like I said, to me, this is just what makes sense to me. Everyone has their own styles of note-taking, so as long as it works for you, that's all that matters. All right. Now, for the next one, we have negative 2x plus 3y squared minus 5 minus y squared minus x minus 2. So we don't have to do any distribution. We just have to collect our like terms. So let's see here. And also too, hit pause real quick and see what you come up with if you want to work this out yourself first. So here we have negative 2x, and then we have this negative x over here. So those are going to be like terms. Then we also have 3y squared and negative y squared. So those are like terms. And then we also have our constants, negative 5 and negative 2. Okay, so like I said, color code does not hurt. So a negative 2x minus x, like red to red, that would be a minus 3x. 3y squared minus y squared, blue to blue, that would be a positive 2y squared. And then negative 5 minus 2, purple to purple, or pink to pink, that would be a minus 7. So that would be your final answer. Okay. Now, as always, yep, there we go. As always, if you have any questions, definitely let me know. Reach out to me, and we'll see what we come up with. But as always, I'm here to help. The next video we're going to knock out is the order of operations, which you guys just got a sneak peek of it just a second ago. So until then, keep working hard.